Hello everyone, just making a quick update video here. I got a question on my last update video, and they were just asking how we could incorporate a microSD card. So, it's pretty straightforward. I have an empty folder here, and I'm going to go ahead and clone my repository. I have it here. Do a git clone. Now, if any of you watched my previous videos, I had mentioned pushing things over with one of the ESP tools or one of the sync tools that I had. I'm not doing that anymore. What I'm doing now is using an extension for VS Code called PyMaker, and I will show that here just a little bit, even though this video is not about that. So, with PyMaker, you kind of set up a configuration file. There's an extension button here for it, and it makes actually just connecting to the ESP32 straightforward. You hit the little lightning bolt icon for whatever serial port it's connected to, and then once you do that, you can click the console-looking button, and then you have access to the terminal there for MicroPython. Now, you can also view what is actually on the MicroPython as well, which is super useful. So if I click this little folder button here, you're going to see up in my files here, it'll show now this little serial COM port folder. And actually, I can actually see files that are on the device itself, which is pretty cool. Which actually, that file is not supposed to be on there. So we're going to delete that. And you can delete files directly off the file system. You can drag files to the file system, and you can control and copy them. So, to get an idea of how PyMaker works, just so I can do this real quick, I'm going to hit Create Project. I'm going to go ahead and select the folder that is in. So for me, that's on my desktop, Python and MicroPython. And then use this folder. It's going to ask you for a name of it. That is the name that I want to use. For the template, I am just going to go ahead and hit the escape key because I really don't want to deal with the template right now. And now you'll see that there's actually this item added here under projects. And if I hit that lightning bolt again, I can actually now sync an entire directory up to that ESP32, which is super useful. And we'll see that here in a minute. Now, I wouldn't want to do it right away because in my file system right now, you'll see that I've got like this new PyMaker file and the README and that sync utility that I had included. And I wouldn't want to push those over to the ESP32. So you do need to actually add some exclusions. And you can see inside this PyMaker file, there is an option to add some exclusions. And that's exactly what I want to do. I'm going to go ahead and add the PyMaker file itself, which I must not have done. So we don't want to upload pymaker.conf if we happen to upload it. And we don't want to upload the tools directory, so I'm going to go ahead and add that to my exclusion list as well. We also don't want to upload that sync to device.py, since that was the utility for the PC. And we don't want to upload anything that happens to say README, so we're going to do star.readme. That way we don't get any of the README stuff. And you can see here it's got like a git ignore and all this other kind of stuff already added to it, which is very nice. If you happen to have like a virtual environment in Python or anything like that, those will automatically be there. And I'm going to go ahead and just click Save. Now, to push up a directory to the ESP32, once you have this configured, it's so easy. You just go to PyMaker and you hit your little upload icon. If you happen to get a little error, I would say don't worry about that. Just hit reset on the MicroPython board and then disconnect and reconnect. I've noticed that sometimes when I do that, there's like a little error, and then usually when I go back to it and try to upload again, it will start working correctly. And you can see here that the sync started and it's uploading those files. I'm actually going to pause the video for a second while this sync goes through. And actually, we'll just leave this running and we'll talk a little bit about the SD card class. So in MicroPython, the functionality for the SD card is actually built in automatically. It's part of the machine library, machine.sd card. And so it's pretty straightforward. You just set up an SD card, a SPI SD card, and you can mount that on the file system and use it just like you would use the file system on the MicroPython. And we'll go ahead and see what that looks like here in just a minute. I actually am going to copy and paste this exact line, and we're going to replace some of these values here in just a moment when I add that to my configuration file. Now, I'm also using a little bit different hardware than I used in my original video. In my original video, I used an ESP32 that had the SSD1306 screen. I'm actually using a separate ESP32 now. It's this board right here. It's from SBC. They're actually a United States company that has like a pick and place machine, and they make a few boards themselves. They seem like a really friendly company, so maybe if you need some board work done or anything like that, What I really like about their boards is that they are very high quality, and they come with a lot of extra VIN and 3.3 volt and ground pins. So if you look at this, you can see it's got 2 grounds up top here, 2 grounds at the bottom. It's got 4 sets of 3.3 volt and 4 sets of VIN. And this is really nice for me because a lot of times when I'm testing something out, instead of using breadboards, which I find to be a bit time consuming, a lot of times I'll just use DuPont cables. And in fact, that's what I did when I did this project. I just grabbed my SD card breakout board, which is this, and my ESP32, which is this board here. And then I grabbed the screen, the I2C screen, and connected them together. DuPont cables, had enough for what I needed, and got everything working. Now, in the end, I actually put these all on one PCB just to make it easier for me. It looks like maybe this library is being used by a few other folks, and so I guess I'll keep a dedicated board together for this in case I make any changes and modifications. I have a device that's dedicated to this project. It'll just make it easier for me, so I'm just going to leave it together, and I went ahead and just soldered everything together and put it on a board. I did want to give a shout out to Easy SBC. I like doing things local, and I think they're based out of Arizona, I think is what I want to say. It might not be Arizona. If I look at this and go to the About page, where do they have it? Yeah, Arizona. So they're here in the United States. If you wanted to talk to them, you'd have to email them. I think they have a number, but they say they don't answer it. But they have a few boards, and I think they have some other parts available that seem to be specific to, say, repairing game arcade machines or pinball machines or something of that nature. But they do have quite a few little parts here. They've got some ESP32s with some built-in charging and some antennas and quite a few other little parts here. But you can even see here, this looks like some sort of specialty ESP32 that accepts some high voltage. I'm not sure what you'd use that for or when you'd use it, but they're a pretty interesting company here in the United States. And again, I like supporting locally. When I did get these boards from them, they were pretty quick. They're very high quality boards. The board that's pictured is this one here, I believe, which is the ESP32 Breakout Development Board. One thing that's also very nice about these particular boards is that they're labeled very well. It's very clear labeling, and they've got 2 very large push buttons, which is very nice. And then if you look here, you can also see they have 2 very large RGBs that are built in. Now, one of them is tied to, I think, the RX and TX pin and one of the SPI pins, but the other one is completely controllable, so you kind of get a free RGB. Now, this isn't amazing today, but these boards were doing this I think 2 or 3 years ago when these were out, which you just didn't find these really nice RGBs. And I would say that even for a lot of the boards that I get now, like the, what is it, that Seed ESP32 or the RPi that comes with some RGB built into it, those ones are all very small. These little RGBs are actually much larger and they're very bright. So it's just a very high quality board. Now, back to the actual video though. So if we look at the pinout for this, which the version that I'm using actually is not the one with the PCB. They have another version with the little Wi-Fi connector on it, and that's actually the one I'm using. Although I do have this board as well. But on this, they have 2 sets of SPI listed. They have this HS SPI and this V SPI. Now, I originally tried to hook this up on H SPI so that I could keep my original pins set for the I2C. However, I had some issues getting things working quite correctly, and in the end, instead of trying to troubleshoot it or figure out why, I just went ahead and used the V SPI set, so the secondary SPI, and it worked just fine out of the box, and I ended up moving that I2C over to pins 22 and 21. So if we look at the SD card page here from MicroPython, you'll see that they actually kind of talk about the ESP32 and these things called slots. Now, they give some information saying that, like, there's different supports for different bit widths, and slot 0 is, say, a built-in one that communicates with flash memory. So there is some complexity here. You might want to read through it. But for this video, all that really matters is that I'm going to be using slot 2, and that these are the pins that I'm going to be using, which are associated with slot 2. And that's all that really matters. So just keep that in mind. All right, so I'm going to go ahead and go up to the SD card here, and we're going to grab this again. And now I just want to test that it is going to work correctly. I am actually going to turn on the ESP32. So I'm going to go ahead and reset that after pushing up that library. And now that I think about it, I shouldn't have pushed up that library, because I bet you if I disconnect and connect to this, if I go ahead and reset the ESP32, it's going to crash. So we're going to see that here in a second, I believe. I'm going to go ahead and open up that REPL again, and I'm going to reset that ESP32. And yes, we get a crash at the right there. And that is because when I did this, I forgot to change those pins that I just mentioned. So from the repository, they're set to pins 5 and 4 down here, but I'm actually using this pin 5 in that vSpy, so I need to switch things over to 22 and 21. So SCL is 22. Let's go ahead and move to the right spot there, 22. And the SDA is 21. I'm going to go ahead and save this. And the other thing that's nice about PyMaker is that you can just push over one file. So you can actually edit on the board as well. So if you were to open up one of these, we could have just edited on the actual ESP32. It is a little slower, but you can actually do that. If we go ahead and open these up, you could do that. I generally don't like to do that. I like to keep them separate from each other, but you can do that on the fly, which is pretty cool. It's very nice. So I'm going to go ahead and right-click this demo.py and then go to PyMaker and just hit upload. We're going to get a question to pick our COM port. Yes, that's what I want to name it. And that's it. It's uploaded. So now I'm going to go ahead and reset my ESP32. There you go. And I'm going to go ahead and turn on my microscope here for just a minute. We're going to get a nice little picture here. And we'll turn on my microscope. And you should be seeing that here. So there is the original animations, and yeah, they seem to be working just fine and running off of the repository. So what do we need to do to add something to this? Well, let's go ahead, and I'm just going to go ahead and cancel this here. So we're going to stop that, and it's going to be in that state there, and that's just fine. And I'm going to go back to this page here, and then I'm going to go, and we're just going to try doing this on the fly first before we add it to the code and documentation. So we're going to start off by importing OS. We want OS because eventually we're going to mount the SD card and the file system, so we need the OS. And then the next thing we're going to need is from the machine, we need the SD card class. That's from machine here. And we're also going to do pins, right? Because we're going to pass in some pins here that we're going to use. So I'm going to go ahead and do the pin class as well. Now you could set these up nice in the file. I'm just going to go ahead and do this for the time being. So I'm going to say from machine import pin. Oops, pin. There we go. And then SD card. Okay, and then I'm going to go ahead and set up this SD card class here. I'm going to grab this. I'm going to say SD equals, and we're just going to modify these values here. So I need to change slot. Oh, is it going to let me jump up to slot here? Well, maybe it won't let me in the REPL. Will the REPL not let me adjust things? It does not seem to be letting me. So maybe that is not what we want to do here. Whoa! Apparently doing this in the REPL was a terrible, terrible idea. All right, let's get back out of here. I will go ahead and just type it in manually, I guess, because apparently the REPL is not happy with that. So SD equals, we're going to do that SD, going to say SD card, and then we're going to go ahead and fill out these arguments. So slot, as I mentioned before, is going to be 2. The width is going to be 1. The CD and WP we don't need to set unless we're doing something specifically with that. That can be used to specify a card detect pin or specify a write protect pin. I'm not worrying about those right now, so I'm just going to go ahead and leave those alone. And I'm going to go ahead and set up SCK, which is going to equal pin 18, right? Let's see this. What is SCK set to? Pin 18, yeah. So SCK is 18, MISO is 19, Mozzie is 23, and then cable select, or not cable select, chip select is going to be 105, or not 105, pin 5 there, IO5. I'm going to go ahead and go back to this here, and let's finish typing this out. So we're going to set this equal to pin 18, and then the MISO pin is going to be pin 19, and the Mozzie pin is going to be pin 23, if I can type 23, there we go. And then the cable select or not cable select, chip select is going to be pin 5. Wonderful. And then the last thing that we need, I think, is that frequency, which was 20 zeros, 20 million, I think, right? 1, 2, 3, 4, 5, 6, 7. There we go. Wonderful. And if we look at that, yep, we got an SD card object. The next step is going to be to mount that. And for that, we're going to, if we look at OS, you can see here that there is an option to mount somewhere. There you go. Oh, mount. Yep, perfect. So I'm going to go ahead and say os.mount, and I want to pass in that object, and then I want to pass the mounting point. And for me, that's going to be /SD. Now, you could do whatever you wanted, but I'm just going to do /SD. And that worked. It mounted. So now I'm going to go ahead and look at the contents of the SD card and see what's in there. So os.steer, and we're going to go ahead and pass in that SD card folder. 0. Is that really 0? I thought I had some stuff on there. I may have to double check and see if I have stuff on there. I want to make sure that I didn't do that wrong. Oh, wild. So this is something I did not realize until I did this sync. So, giant warning. If you're using PyMaker and you do the sync, it will erase everything on the ESP. And if you happen to have this mounted at the time that you do that sync, it will also erase everything on the SD card. So giant warning there, back up your SD card when you're playing with this if you happen to do this, because apparently I wiped off all of the images that I had, and I'm going to have to add those back real quick. Okay, so all of the files have been added back to the SD card. I'll put it back into my little SD card breakout board. One thing you do have to note with MicroPython is that if you remove the card, you have to reset the ESP32. It's a known bug, and there is a Git issue open, or a GitHub issue open for it, but it has not been fixed as of yet. Alright, so I've restarted my ESP32, and now all that wonderful work that I did, I'm going to have to do again. So we're going to go ahead and cancel this out, and let's go ahead and grab, oh no, we decided that we couldn't grab it because it wasn't going to work. Alright, so let's show this one more time. Let's see, well, let me use some of my previous commands. Actually, I can probably just go up here and, yeah, copy and paste this right here. So let's go ahead and do an import OS, and then import, from machine, import pin, and SD card. There we go. I can paste that line once again, and that worked. And then the os.mount, and then the object, and the mount point, SD. There you go. And now let's try once again. So remember, when you're doing stuff with that SD card, if you decide to go ahead and mount or go ahead and upload everything with PyMaker because it's so easy and convenient, just be careful. It erases everything, and if you have the SD card mounted at the time, it will erase the SD card, which I know sounds terrible. I wonder if there's maybe a way to mount it differently so that it doesn't do that, or an option inside of PyMaker to change that. I'll have to research that later. So os.listdir, and let's go ahead and look at that SD card. Wonderful. That's what we'd expect. System volume information, you could ignore that. That's something that the file system puts on there. You just don't even worry about that. But the kitty and the rocket is exactly what we would want to see. So we should see like something like 12 files inside kitty. Yep, there we go. And then once again, we should see about 40 files inside of rocket, which is exactly what we see. Wonderful. So we know it's working. We can read it, and we're just going to add it exactly like we have here. So I'm going to go ahead and just add a animation to this. So let's go to our first animation here. We get this Mario animation. Actually, I suppose we actually need to add that code there. So I'm just going to say import OS, and then import from machine import pin and pin and SD card. There we go. We're not using them, but we're importing them. That's fine. And it's going to look like there's an error because this is just code highlighting, and it doesn't know what machine is because you'd have to stub it out and everything else. So just ignore the fact that that's like that. Don't worry about it. It'll work. And then right under here where we did the display setup, I'm going to go ahead and do the SD card setup. So that was that line right there that I copy and pasted. And then it was the, we'll go ahead and just copy and paste this as well. There we go. So our code should now mount that automatically. And so now all we need to do is grab that particular folder when we go ahead and do an animation. So right after the Mario dance animation, we're going to go ahead and add 2 more animations. And actually, let's do it before that. So it'll be our very first animation. We'll leave the rest of these on here, the single slide ones, and we're going to go ahead and just add that animation there. Oops. We'll say new SD animation demo. And actually, we don't want to do that there. So we have, oh yeah, we do. I don't know what I'm talking about. There we go. And we'll do 2 of these, right? Because we have a kitty one and we have a rocket one. And all we're going to need to do now for this is actually just put in SD. And for the first one, it's going to be rocket. Get rid of the rest of this. Let's say that we're shooting for 30 frames a second. So we'll say 33 there. Frame count, we know that there is 40. 40 frames, the duration is 40, and our start frame is 1. Perfect, and we're not going to reverse them. Actually, you know what? Let's do this second one, and let's reverse it. So right after the first animation, we'll add the second animation, and actually we will choose true for reverse. So the rocket will land and then take off again, and that's just fine. And we'll put something artificial in here, so we'll say time.sleep. We'll just add 1 second here, just so we can see that happen. And then for the next one, we will add SD, so /SD/kitty. And there was 12. And we're going to go ahead and slow this down a bit. So 33 is going to be kind of fast for that cat one. Let's just take it down to, say, 22. And then we'll go ahead and, oh, actually, that would be speeding it up, not slowing it down. So, yeah, let's go ahead and slow it down, which would be 66. Yeah, I wasn't thinking about that. That's not actually slowing it down. That's speeding it up. So we would, we're going to go ahead and just leave this at 66 up here. And we'll keep this at, we're actually going to change this, I think, to 132. Frame count, there was only 12. The duration is 12. The start frame is 1. All right, so that is just fine. And that should be all we need, actually, to do this. So let's save this. I'm going to go ahead, and I'm not going to do that full upload. I'm just going to do the single file, PyMaker, upload to device. Okay. And if all goes well, I'm going to turn back on the microscope here. There we go. And if all goes well, when we reset the board, we should see that, bumped it there just a little bit too much. We should see our normal slideshow. So there's that. And Pokemon. Okay, our slides are going through here. And now we should see our rocket ship. Oh, we got an error. So did I do something wrong? What does it say? Display.ppm. Well, possibly I typed something in wrong here. Give me just a moment. And indeed I did type something in wrong. I typed in rocked instead of rocket. Sure enough, if the file is not there, it is simply not going to work. It's going to crash because there's no sort of error handling in this. So double check the names, hit save again, upload again real quick. Yes, yes, yes. And reset the board once again. Try this again here. Okay. So we're working through. There's our Pokemon. There's our Mario. There's our Tetris. There's our 3 starter Pokemon. And sure enough, here is our rocket ship. Lands. Wonderful. And goes ahead and takes off. Fantastic. And then there's our cat jumping around. Now that's a little bit slow animation-wise, so maybe we want to do that a little bit differently. In fact, yeah, I'm going to do that real quick here. So for the cat, because that was so short. Now for the rocket ship, I thought that time was okay. I really wouldn't mind that rocket ship's 33. I really wouldn't mind if they were both 33, actually. Let's find this one reversed. For this kitty, though, this was way too slow. I was way wrong with that. That was very slow. I'm going to change that back to here. And I'm actually going to go ahead and just throw in a while loop. So we'll say KT equals, let's say we want to loop through it, say 5 times. And we'll say while KT. And we're just going to go ahead and indent this. And then we'll say at the end of this, KT minus equals 1. There we go. So let's get a nice little while loop here. I'll go through it a few times, and we'll see what that looks like. Go ahead and upload this to the board. I'm going to have to hit Control-C here. There we go to get to REPL. And once I do that, I can upload to my board. You do have to do that with PyMaker. It won't interrupt your current sketch. You have to make sure you're at the REPL, and then you can upload. Okay, and then I'm going to go ahead and reset. Oh, wiggle that again. Again, Pokemon, there's the starters, the Mario Kart. Sorry for the wiggle there. And sure enough, there's a rocket ship, lands, goes ahead, takes off. And now let's look at our kitty. There we go, a little bit faster on the kitty. And sure enough, we get our while loops and we have our kitties running. So that is how easy it is to add things from the SD card. You simply need to go ahead and import OS, a machine, define your SD card wherever you happen to have it for the SPI interface, mount it, and then you can access it just like any file. So I hope that was helpful. Sorry if it was a little long-winded. Yeah, if you have any more questions, just go ahead and let me know. Thanks, guys. You have a wonderful day and a wonderful year.